Introduction. Anything that has mass and volume is matter. Matter is also defined as anything with the property of inertia. All of the solids, liquids, and gases that you may encounter in your daily life would be classified as some type of matter. You are familiar with the taxonomy of living things from biology. Objectives. At the end of this lesson, you'll be able to understand the difference between elements, compounds, and mixtures, know about the properties of solution, understand the difference between suspension and colloidal solution, understand the concept of separating two miscible and two immiscible liquids, and understand the separation of components of air. Classification of matter. Substance. A substance is a material with a constant composition. This means that the substance is the same no matter where it is found. NaCl, H2O, Ne, CO2, and O2 are all substances because their composition will be the same no matter where you find them. All elements and all compounds are defined as substances. Elements. Elements are substances that are made up of only one type of atom. At this time, there are 113 known elements, most of which are metals. The symbols shown on the periodic table represent the known elements. Even atoms are made up of smaller particles, but they are not broken down by ordinary chemical means. Compounds and phase. Compounds. Compounds are substances that are made up of more than one type of atom. Water, for example, is made up of hydrogen and oxygen atoms. Carbon dioxide is made up of carbon and oxygen atoms. Table salt is made up of sodium and chlorine. Compounds differ from mixtures in that they are chemically combined. Unlike elements, compounds can be decomposed or broken down by simple chemical reactions. Phase. A phase is any region of a material that has its own set of properties. In a chocolate chip cookie, the dough and the chips have different properties. Therefore, they represent separate phases. Pure gold, which is an element, would only contain one phase. Italian dressing would clearly represent several phases, while a solution of salt water may only contain one phase. Homogeneous materials and mixtures. Homogeneous materials. Any material that contains only one phase would be considered homogeneous. Elements like hydrogen, compounds like sugar, and solutions like salt water are all considered homogeneous because they are uniform. Each region of a sample is identical to all other regions of the same sample. Mixtures. Mixtures are made up of two or more substances that are physically combined. The specific composition will vary from sample to sample. Some mixtures are so well blended that they are considered homogeneous, being made up of only one phase. Other mixtures containing more than one phase are called heterogeneous. Solutions. Solutions are a special type of homogeneous material because unlike compounds, the parts of a solution are physically, not chemically combined. When you mix a glass of salt water, the salt does not chemically react with the water. The two parts just mix so well that the resultant solution is said to be uniform. Iced tea, coffee, metal alloys, and the air we breathe are some examples of solutions. Solutions are made up of two parts: the solute, which gets dissolved, and the solvent, which does the dissolving. In the case of salt water, salt is the solute and water is the solvent. Heterogeneous mixtures. Heterogeneous mixtures are made up of more than one phase, and they can be separated physically. Chocolate chip cookie, a tossed salad, sand, and a bowl of raisin, bran cereal are all examples of obvious heterogeneous mixtures. Element. An element is a simple substance which cannot be further divided into any simpler substance by ordinary chemical means. Copper, hydrogen, iron are some examples of elements. There are about 109 elements known to mankind. Uranium is the heaviest element and hydrogen is the lightest element. One element differs from another because each has its own special kind of atoms. The figure represents atoms of an element A and those of an element B. An element cannot be broken down into simpler substance because its atoms are indivisible. When two elements combine, atoms are neither created nor destroyed. Thus, the mass of the product is the same as that of the reactants. If atoms of element A combine with atoms of element B, the proportion of mass of the elements in the resulting compound molecule will be constant. Thus, if one atom of A combines with two atoms of B, the resulting compound molecule will always have A and B in 1:2 ratio by mass as shown in the figure. In a mixture, however, the atoms do not combine and they may be present in any proportion. Compounds. A compound is a pure substance made up of a chemical combination of two or more elements in a definite proportion. A compound contains two or more kinds of atoms chemically combined together to form new molecules. Water is one such example of a pure substance made up of a combination of hydrogen and oxygen combined in the ratio of 2:1 by volume and 1:8 by mass. Hydrogen and oxygen are molecules of elements that exist as gases. But if two atoms of hydrogen are combined with one atom of oxygen under special conditions, then one molecule of water is formed. Therefore, water is a compound. The compound, namely water, is formed by the combination of two elements, hydrogen and oxygen, in the proportion 1:8 by weight. Compounds are homogeneous materials which contain two or more elements combined in a definite proportion by weight. Examples of compounds are common salt, carbon dioxide, etc. Some common compounds and their constituent elements. Differences between elements and compounds. Mixtures. When two or more elements or compounds are brought together, they mix together without losing their individual properties. These are called mixtures. A mixture may be defined as that containing two or more substances in varying compositions. Like air is a mixture of several gases. It contains elements such as oxygen, nitrogen, and compounds such as CO2 and water vapor. Activity. A mixture of iron and sulfur is taken in a dish. A magnet is brought near this mixture. What happens to the mixture? Only the iron fillings get attracted to the magnet. Add carbon disulfide to the mixture. What do you notice? The sulfur particle dissolves while the iron fillings remain unaffected. What do you understand from this activity? We can understand that individual components of a mixture retain their original properties. Here, iron retains its property of getting attracted to a magnet, and sulfur retains its property of dissolving in carbon disulfide. So mixtures can be classified as heterogeneous or homogeneous. Solutions are homogeneous mixtures at the particle level. Heterogeneous and homogeneous mixtures. A heterogeneous mixture is usually apparent at the microscopic level. It is obviously a mixture of two different substances, salt and pepper, oil and vinegar, etc., that may or may not be in different physical states, liquid and gas state. Homogeneous mixtures appear to be one substance at the macroscopic level. This means that only one physical state is apparent, that is, only solid, only liquid, etc., and two more substances are mixed in such a way that it is impossible with the naked eye to distinguish the individual substances. An example is margarine. Margarine is usually made up of at least 3 substances. However, all the substances mix to produce what looks like one substance. Differences between compounds and mixtures. Activity. To study the difference between a mixture and a compound, take 56 gram iron fillings in a china dish. Mix 32 gram sulfur powder into it. Mix them thoroughly. In another china dish, take 56 gram iron fillings and 32 gram sulfur powder. Heat this dish to a high temperature. Now take a magnet. Pass it through both the dishes. Record your observations. When the iron fillings and sulfur powder are taken in the china dish, they formed a mixture. Iron and sulfur do not combine with each other. Both sulfur and iron retain their own properties. When we bring a magnet near the mixture, the iron fillings get attracted to the magnet. Solution. A mixture of 2 or more substances can be a solution, a suspension, or a colloid. The substance is said to be in a state of molecular dispersion when the particles of a pure substance are of molecular atomic or ionic size. A solution is a homogeneous molecular dispersion of 2 or more substances. It can also be stated that a solution is a homogeneous mixture of 2 or more substances. Homogeneous means uniform throughout. Thus, a solution which is a homogeneous mixture will have a uniform composition throughout. Sugar solution is a clear liquid, and we cannot distinguish the sugar particles from the water molecules even with the microscope. Some of the examples of solutions are salt solution, sugar solution, copper sulfate solution, and solution of acetic acid in water, which is vinegar. The liquid in which the substance is dissolved is called a solvent. The substance which dissolves in a solvent to produce a solution is called solute. In sugar solution, sugar is a solute whereas water in which it is dissolved is called solvent. Generally, in any solution, the amount of solute present is lower than that of a solvent. Types of solutions. Solutions can be classified depending upon the amount of solute dissolved. The unsaturated solution is one in which more solute can be dissolved without increasing the temperature. A saturated solution is one in which the maximum possible amount of a solute is dissolved at a given temperature. In a saturated solution, dissolved and undissolved solutes are in equilibrium with each other. A supersaturated solution is one in which the amount of solute is more than the saturation concentration. Properties of a solution. A true solution is a homogeneous mixture. The components of a solution cannot be separated easily, such as through filtration. The size of a solute particle is extremely small and of an order 10 raised to the power minus 8 cm in diameter. The particles of a solution cannot be seen even under a microscope. The solution is clear and transparent. The solutions are stable and solute particles do not settle down when kept undisturbed. Suspension. Some substances do not dissolve in liquids. Small particles of such substances remain suspended in the liquid. For example, sand, mud particles remain suspended in water. Similarly, solids may remain suspended even in gas. These mixtures are called suspensions. Suspension is a heterogeneous mixture in which small particles of solids remain suspended throughout the mass of the liquid or gas without getting dissolved. Properties of suspension. A suspension is a heterogeneous mixture in which small particles of solids remain suspended throughout the mass of the liquid or gas without getting dissolved. The particles in a suspension are visible even to the normal eye. The diameter of the particles is of the order 10 raised to the power minus 5 cm. The particles in a suspension can be separated from the liquid by filtration. The particles of suspension will settle down on standing. Colloids. A colloidal solution appears to be homogeneous, but it is actually heterogeneous when viewed through a powerful microscope. A colloid is in between a true solution and suspension. A colloid is a solution in which the size of the solute particles is bigger than that of a true solution, but smaller than that of a suspension. Some common examples of colloids. Tyndall effect. A colloid scatters a beam of light passing through it. It means that a beam of light passing through such a colloid is visible. If a beam of light passes through a colloid kept in a dark room, the path of light can be seen due to the scattering of light by colloidal particles. The same effect can be generally observed when a beam of light passes through air containing dust. This scattering of light by colloidal particles is known as Tyndall effect. This effect is not shown in true solutions. In liquids, the Tyndall effect can be easily seen by using a laser pointer. If you dilute milk to where it is almost clear, or if you have any type of solution, such as colloidal silver, then the beam of the laser can be easily seen as it travels through the liquid. Separation of mixture and two immiscible liquids. Separating the components of a mixture. Heterogeneous mixture can be separated by simple physical methods like hand-picking, filtration, etc. But special methods are needed to separate components of a mixture. Separation of two immiscible liquids. The separation of two immiscible liquids can be done by using a separating funnel. Activity. Take a separatory funnel and the mixture of diethyl ether in a separating funnel. Allow it to stand undisturbed for some time. The layers of diethyl ether and water get separated. Place a receiving flask under the funnel, remove the stopper from the top and open the stopcock. Pour out the lower layer of water. Close the stopcock of the separating funnel as diethyl ether reaches the stopcock. Separation of two miscible liquids. Separation of two miscible liquids by distillation. Activity. Take acetone and water in the distillation flask. Insert thermometer in one hole. Connect the side tube of the flask to Liebig's double-walled condenser. Now heat the liquid with a gas burner. The acetone vaporizes. The vapors produced by evaporation escape through the side arm into the condenser. The cold water circulating in the condenser condenses the acetone vapor into liquid which collects in the receiver. The water is left in the flask. Sublimation. Substances like ammonia chloride, naphthalene, camphor, etc. change directly from solid to gaseous state on heating. For these substances, sublimation technique is adopted. Sublimation is a process of conversion between the solid and the gaseous phases of matter. Activity. Take a mixture of sand and iodine in a china dish. Cover the dish with an inverted funnel. Heat the mixture gently with a burner. Violet fumes of iodine vapor can be seen to rise through the funnel. The iodine vapor condenses to a solid on the cooler surface of the stem of the funnel. Now stop the heating when no more vapor comes out of the mixture in the dish. The pure iodine crystals are scraped out. The non-sublimable sand remains in the dish. Iodine is a common example of a substance that visibly sublimates at room temperature slowly. Crystallization. A hot solution of a substance on cooling deposits crystals of the pure substance. This process is called crystallization. Activity. Take about 100 ml water in a beaker. Acidify the water with few drops of dilute sulfuric acid. Heat the water. When it starts boiling, add copper sulfate powder slowly with continuous stirring till a saturated solution is obtained. Now filter the solution. Allow it to cool. After some time you will see blue-colored shining crystals of copper sulfate in the solution. Physical change. To understand the difference between a pure substance and a mixture, we should have the knowledge about physical and chemical change. Color, hardness, rigidity, fluidity, density, melting point, boiling point, etc. are the physical properties. Physical change. The interconversion of states is a physical change because these changes occur without a change in composition and no change in the chemical nature of the substance. For example, although ice, water, and water vapor all look different and display different physical properties, but they are chemically the same. Chemical change. If there is a change in chemical nature of the substance, then it is called as chemical change. Example 1. Both water and cooking oil are liquid, but their chemical characteristics are different. They differ in odor and inflammability. We know that oil burns in air, whereas water extinguishes fire. It is the chemical property of oil that makes it different from water. Example 2. Burning is a chemical change. During this process, one substance reacts with another to undergo a change in chemical composition. Chemical change brings change in the chemical properties of matter, and we get new substances. A chemical change is also called a chemical reaction. Summary. Let us summarize what we have learned. Matter is classified broadly as elements, compounds, and mixtures. Elements are substances that are made up of only one type of atoms. Compounds are substances that are made up of more than one type of atoms. Mixtures are made up of two or more substances that are physically combined. A solution is a homogeneous molecular dispersion of two or more substances. The liquid in which a substance is dissolved is called a solvent. The substance which gets dissolved in the solvent is called a solute. Solutions are classified as unsaturated, saturated, and supersaturated solutions. Suspension is a heterogeneous mixture in which small particles of solid remain suspended throughout the mass of the liquid or gas without getting dissolved. A colloid is in between a true solution and a suspension. A colloid is a solution in which the size of the solute particles are bigger than that of a true solution but smaller than that of a suspension.